All right, so like I said, we're going to break this factoring down into different types. We're going to start with two of the easier things today. We're going to start with just looking at pulling out a GCF. That is what you look for every time when you begin, before you do anything else, is looking for what, if anything, the terms have in common, and we can factor those terms out. So we're going to start with that first polynomial, 2x to the fourth minus 4x to the third plus 8x squared. And again, the very first step when we factor before we do anything else is to always look for a GCF. What is it that they have in common, both numerically and variables? So if I'm looking at 2x to the fourth, 4x to the third, and 8x squared, what number do they all have in common? A 2. And then variables, they have how many? How many do they have in common? 2, okay? So my GCF in this is going to be 2x squared. So what I'm going to do is I'm going to start by taking and pulling out or factoring out that 2x squared. And then I put a parenthesis. And then what I'm going to do is just divide each term by that GCF and to say what's left. That's what I'm going to always ask you, what's left. So if I take 2x to the fourth and I divide it by 2x squared, what's left? Just x squared, right? And then I'm going to bring down my minus sign. And then if I take 4x to the third and I divide out 2x squared, what's left there? 2x. And then I'm going to bring down my plus sign. And then if I take 8x squared and I divide it by 2x squared, what's left there? 4. Now, normally from here, we would look at what's in our parentheses, the x squared minus 2x plus 4, and try to continue to factor. But since we haven't really talked about factoring anything, that actually doesn't factor any further. So this is all I can do. Sometimes when you factor, all you can do is pull out that greatest common factor. You can't continue from there. You can't break it down any further. Does that make a little bit of sense? Okay. All right, what I want you to do is try number 2. Look at the two terms, 10ab to the third and 15a squared b squared, and I want you to factor out what they have in common, both variables and numerical values. So if I'm looking at 10ab to the third minus 15a squared b squared, what is it that they have in common? What number do they have in common? 5. And then as far as variables are concerned, how many a's do they have in common? Just 1. And then how many b's do they have in common? 2. So my GCF, what I can factor out is 5ab squared. Okay. And then what I'm going to do is divide each one of those terms by that 5ab squared and tell what's left. If I take 10ab to the third and divide it by 5ab squared, what's left? 2b. Bring down that minus sign. And then if I take 15a squared to b squared and I divide it by 5ab squared, I'm left with 3a. And again, 2b minus 3a cannot factor any further, so that is all we can do there. So again, sometimes all you can do is pull out a GCF and you cannot go any further. But again, before we begin any factoring problem, the very first thing we're going to ask ourselves, do we have a GCF? Do we have anything in common? Is everybody okay with those two? All right, if you will, take a minute and write down number 3. And while you're doing that, factoring can be taught many different ways. And it depends on what teacher you had that originally taught you how to factor as to how you learned it. I'm going to talk you through it the way that I teach it. If you do it a different way, that is perfectly acceptable, okay, as long as you know what you're doing. I just have a couple of rules that make it a little bit easier. Sometimes when people start worrying about numbers with signs and all, it just gets really confusing. So I'm going to just kind of talk you through how I teach it. You can either think of it that way, or you can think of it however you were originally taught to factor. So the first one says, or number 3 says, x squared plus 10x plus 9. First things first. Do they have anything in common? Do all 3 terms have something in common here? Right, and we're starting with the easy trinomials today. Okay, 3 terms. And they're easy because, or they are the easiest ones, because there is nothing in front of the x squared besides 1. Okay? When I start putting numbers in front of x squared, that's when it gets a little bit more challenging. But we're going to do that tomorrow. So today we're going to stick with the easy trinomials where it's just a 1x squared that we have to worry about. So this is the way that I think through it. First of all, and I wrote one of them up. I'll write the other one up next. But these two, if you look at both of these, 3 and 4, if you look at the second sign, and when I say second sign, I mean the one that comes second when you're looking from left to right. Here's a plus sign, right? This is also a plus sign. So my rule is, or what I think about, is if the second sign is a plus, then my signs are always going to be the same in my 2 parentheses. They will be the same. And they are going to be whatever the first sign is. So if the first sign is a plus, then in my 2 parentheses, I will have 2 plus signs. If the first sign is a minus, then in my 2 parentheses, I will have 2 minus signs. Now, here's the way I think about it. Sorry. And I'm just underlining because I can't point to it up there, and also it's better for the video. So what I want to know is I want to know numbers that multiply to give me 9 and add to give me 10, okay? I'm not worried about the signs yet. I don't care about positives and negatives or anything like that. All I want to know is what 2 numbers multiply to give me 9 and add to give me 10. So think about your factors of 9. 1 and 9, and then 3 and 3, right? Those are the only 2 pairs of factors. Which pair adds to give me 10? 9 and 1, okay? So what I'm going to do is I'm going to set up my 2 parentheses. I'm breaking down my x squared by putting an x in the front of both of those parentheses. And then we chose the factors 1 and 9. It does not matter which parenthesis I put those in. What matters is my sign placement when I get ready to do that. Is everybody okay so far? All right, now in this case, my second sign I have highlighted is a plus sign. That means that my signs in my parentheses are going to be the same. Okay, and they are going to be whatever this first sign is. In this case, the first sign is a plus. So in my parentheses, I'm going to put a plus in both of them. Now, if I wanted to check myself, how could I do that? How could I check to make sure that's correct? Just multiply it back out, just like we were doing on the quiz, right? We would just FOIL it back out. As long as I end up with x squared plus 10x plus 9, I know I'm correct. Okay. Also, when you look into your parentheses, a couple of things we need to look for in here and here. In order for it to be completely factored, those cannot be broken down any further, and they also can't have anything in common. Meaning I can't have like a 2 and a 4 in the same parentheses, or a 3 and a 6 in the same parentheses. I can't have 2 numbers that have something in common, which I don't here, because again, these are the easy ones. Okay, just a couple of things we're going to be looking for. So that's my answer. That's exactly how I leave it. I could also write x plus 9 times x plus 1. The order of the parentheses doesn't matter. What does matter is that you have the 9 and the 1, and you have the 2 plus signs in your parentheses. Listen. So what I want to know is, when I look at this problem, I want to know the numbers that multiply to give me 9, okay? And I want them to add, because that's a plus sign, to give me 10. So if I think about the 2 factors of 9, it's 1 and 9 and 3 and 3. And the ones that add to give me 10 would be 1 and 9. Does that make a little bit of sense? Okay. Is everybody good? All right. Now the second one, same thing here. First things we're going to ask Do I have a GCF? Does x squared, 12x, and 36 have anything in common? No. So what I want is I want the numbers that multiply to give me 36 and add to give me 12. Again, I don't care about the signs yet. All I'm thinking about is what numbers multiply to give me 36 and add to give me 12. Now, some people can think of it right off the bat. Some people need to make a list. I always start with 1 and the number, okay? 36 actually has quite a few factors. So 1 and 36, does that add to give me 12? No. Let's see, 2 and 18, does that add to give me 12? Nope. 3 goes in 12 times, that doesn't add to give me 12. 4 goes in 9 times, does that add to give me 12? 5 doesn't go into 36, but 6 goes in 6 times. Does that add to give me 12? It does, okay. So I'm going to use this pair of factors, so I'm going to set up my 2 parentheses. Again, to break down the x squared, I just put an x in front of both of my parentheses. And then because I chose 6 and 6, I'm going to put those in the back of the parentheses. Maybe. And then again, using this rule, my second sign is a plus sign, which means in my parentheses, my signs are going to be the same. And they are going to be whatever that first sign is, which in this case is a negative. So they'll both be negative. And again, once we get more into our factoring, we will want to check to make sure that those 2 parentheses cannot factor any further. But because we're just beginning, they can't. And that's our answer. Is everybody okay? All right. Now I actually want to adjust that a little bit, and I'm going to write the next one up. I'll adjust that one in a minute. So with these, again, starting with 5, first of all, do I have a GCF, x squared, 2x, and 15? No. Now this one is a little bit different because this time, what kind of sign is my second sign? A negative. So this is how I think about it. And I wrote it in words on the board, but I'm going to talk to you about it as we go through this problem. I want numbers that multiply to give me 15, but this time I don't want them to add. I want them to subtract to give me that middle term 2. Okay, I don't care about the signs yet. I just want to know what numbers multiply to give me 15 and subtract to give me 2. So we think about our factors of 15. 1 and 15 and 3 and 5. Which pair subtracts to give me 2? Again, we're not worried about positives and negatives yet. I just want to know which ones, 1 and 15 or 3 and 5 subtract to give me 2. 3 and 5. Okay, so, whoops. Again, we're going to split up our x squareds. I'm going to put 3 in one parenthesis. I'm going to put 5 in the other. That doesn't matter. What does matter is the placement of the signs, which we'll do in just a minute. And then I'll pause so that you guys can write that down if you want, and I'll fix this one over here. So far, so good? All right. So when my second sign is a minus, what that tells me is inside my parentheses, my signs are going to be different. What I mean by different is you're going to have one plus and you're going to have one minus. Okay. This first sign right here, this plus sign, is going to go in front of the bigger number. What's bigger, 3 or 5? 5. So I'm going to put a plus 5, which means in front of the 3 I have to put a negative. Okay, that's how I think about this one. If the second sign is a minus, this is what this says. If the second sign is a minus, we want the factors of the last term, which in this case was 15, that subtract to give the middle term, which was 2. Your signs will be different, and the first sign goes in front of the bigger number. So I'm going to pause just for a second. All right, first question, x squared minus 6x minus 27. Do I have a GCF? No. All right, I want numbers that multiply to give me 27 and subtract to give me 6. Numbers that multiply to give me 27 and subtract to give me 6. If you need to make a list of factors, you always start with 1 in the number. Then you go down your list until you repeat a factor. That's how you know you're done. So 1 and 27, and then what? 3 and 9. So which pair subtracts to give me 6? 3 and 9. Okay, so we're going to put x and x. I'm going to put my 3 in one and not a 6. My 9 in the other. And then that's when I think about my sign placement. How many of you, when you were taught, you had to figure out like -3 and +6, or you were taught to think about the signs as you go through it? Okay. To me, that just makes it a little more confusing. If you can just remember these 2 rules, it's easier to just think about the numbers and then put the signs after you're done. Okay. Again, if the second sign is a minus, my signs are going to be different. And this first sign goes in front of the bigger number. So where would that negative go? In front of 3 or 9? 9. Okay, and then that means the plus goes in 3. Is everybody okay with those? All right. Oops, sorry. Okay. I would like for you to try both of those. One minus, 1 plus. Try both of those. I'm not forcing you to think about it the way I do. You do whatever you're comfortable with that helps you get to the right answer. And again, when you're doing these, the order of the parentheses doesn't matter as long as you're following it correct. I usually take it my small number first on my that's how I have it. But it has to be done that way. With number 7, x squared plus 4x minus 21. Do I have a GCF? Anything in common? No. All right. So I want numbers that multiply to give me 21 and subtract to give me 4. I got 1 and 21, and I've got 3 and 7. Which pair subtract to give me 4? 3 and 7. Again, it doesn't matter if I put the 3 or the 7 in the first or second parenthesis. What does matter is my sign placement. Because this is a minus, that means I want different signs. And the first sign goes in front of the bigger number. So where do I put the plus? In front of 7, which means the 3 is going to be a minus. Different signs, one of each. What about 8? X squared minus 20x plus 36. Do I have a GCF? No. All right, I want numbers that multiply to give me 36, but this time I want them to add to give me 20. 1 and 36 do not add to give me 20. What about 2 and 18? Do those add to give me 20? They do. Okay. This time, because my second sign is a plus, my signs are going to both be the same. They're either both a plus or both a minus, and they will be whatever that first sign is, which in this case is a minus. You feeling okay with those? All right, let's take a look at this. Write down number 9. We're going to walk through this one together, then I'm going to let you try number 10. Two x squared plus 20x plus 48. First things first. Do I have a GCF? What do they all have in common? A 2. So the first thing we have to do is we have to do like we did on questions 1 and 2 is we have to factor out what they have in common. And then we have to write what's left by dividing each term by that 2. But now, because we've talked about a little bit of factoring, what we need to do is we need to look at that trinomial inside the parentheses, the x squared plus 10x plus 24. And we need to ask ourselves, are there numbers that multiply to give me 24 and add to give me 10? Okay, think about, we're not worried about the 2 on the outside. That's just going to continue to come down. I want to know, are there factors of 24 that add to give me 10? So I'm going to start making a list. It's 1 and 24. Then it's 2 and 12. That doesn't work. 2 and 12 subtract to give me 10, but I don't want them to subtract to give me 10. I want them to add to give me 10, so that's not going to work. All right, 3 and 8 does not add to give me 10. What about 4 and 6? Does that add to give me 10? Okay. So when we do this, that 2 that we pulled out stays in the front. We still set up our 2 separate parentheses. If you lose that 2, then you don't have the correct answer. So make sure if you factor out a GCF that as you continue to factor, you bring it down with you. We're going to split up our x squared. We chose 4 and 6. Are my signs going to be the same or different? They're going to be the same because my second sign is a plus. And what are they both going to be? Plus. So my final answer for this one is going to be 2 times x plus 4 times x plus 6. Or you could write 2 times x plus 6 times x plus 4. As long as that 2 is in the front. You factored it out, so it has to come down with you as you go. Is everybody okay with that one? All right, try number 10 then. Look for a GCF first. If they have one, pull it out and then continue to factor. If they don't have one, then you just try to factor from there. Again, every problem that we factor, the very first question we always ask ourselves, do we have a GCF? If we do pull it out, then look at what's left and factor it the same way we've been factoring everything else. What numbers of the last term either add or subtract to give you a middle term, and you can choose your signs at the very end. this part right down that middle. We don't want to split it into pieces just right. Alright, so you pull out the filter right now, and then do it for x. The very first thing you want to do is divide each term, and don't set that up yet. Yeah, just that one. Alright, so what you want to do is divide each one of these by 3. So if I take this 3 away, what's left? X. If you divide 6x by 3, what's left? How many can we use in All right, 3x squared minus 6x minus 45. Do we have something in common? What? 3. So we're going to take and we're going to factor out that 3 first. And what I need to do is say what's left once I divide every term by 3, which is going to be x squared minus 2x minus 15, correct? Okay. After that, we are only focused on what's inside here. That 3 is going to just stay on the outside. What I want to know is I need numbers that multiply to give me 15 and subtract to give me 2. What numbers multiply to give me 15 and subtract to give me 2? 3 and 5, okay. And then we figure our signs. The second sign is a minus, so that means my signs are going to be different. That means the bigger sign, or I'm sorry, the first sign goes in front of the bigger number. What's bigger, 3 or 5? 5. So we do a minus 5 and a plus 3. And that's how we leave our answer there. Make a little bit of sense? Okay. All right, last one. Write this down. I want you to actually try it. Do I have GCS? No. So what I want this time is I want numbers that multiply to give me 12, and what do I want them to do? Add to give me 9. Okay, so 1 and 12, 2 and 6, 3 and 4. Do any of those add to give me 9? Okay. That's going to happen every now and again. You're going to find a problem that you don't have a pair of factors that either add or subtract to give you what you want. Does anybody know what we call it? It starts with a P. Okay, think about numbers like 3 and 5. You only have 1 and that number, 1 and 3, 1 and 5. What are those numbers called? Prime. Okay, so if you come across a problem that does not have a pair of factors that do what you want them to do, then we just say that that can't be factored. So we call it prime. It doesn't break down into something times something else. Does that make sense? Anybody have any questions? All right.